Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Faris Ahmad Al-Hadrami. So I will start our group discussion for group D in our assignment task. Firstly, I will give a technical briefing first with Afiq bin Naim. So here we go. This is the question that we are required to design a three-phase system with star-connected alternator and unbalanced star-connected load. Your load should consist of RL or RC combination. Discuss with group on how to calculate the line of phase voltage, current and power of the system. Support the design with manual calculation and simulation using multisim. So firstly, I will give the definition of three-phase WYE star connection. As shown in figure 5, in the three-phase WYE star connection, the three single-phase LC alternator winding or motor or transformers winding are wired in parallel with the same reference lead of each winding connected. One is to supply conductors L1, L2 and L3. Next, the three-phase WYE wiring configuration is referred to as a voltage multiplier or divider. This reference comes from the three-phase AC line voltage, normally referred to as either the line-to-line voltage or just line voltage V line. It is measured between any of the three supply lines in the three-phase alternator or motor or transformer WYE wiring configuration. So that's all from me. We will continue with Afiq. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afiq bin Naim and I will continue the explain from Faris about technical briefing from this assignment task, and I will explain about three-phase unbalanced load meaning. The loads are in unbalanced when each load phase has different impedance or power factor. In that case, current and power in each phase will be different. In practice, we may come across the following three-phase unbalanced load: 4-wire star connected unbalanced load, unbalanced connected load, and unbalanced 3-wire Y connected load. Then, the difference between three-phase balanced and three-phase unbalanced system. For three-phase balanced system, waveform is perfectly sinusoidal in terms of magnitude and phase shift of 1 to 0 degree. Current flowing through each phase is same. No current flow through the natural. Power loss is very low or not present. For three-phase unbalanced system, waveform are disturbed in terms of magnitude and phase angle. Current flowing phase is not same. Neutral needed. Power losses are more. So that is a difference between three-phase balanced system and three-phase unbalanced system.
Assalamualaikum. I want to discuss about the calculation. So we got ZR, ZY, ZB, and the amount is 8 plus J 0.314, ZY 10 ohm, ZB 8 minus Z 0.011. So to get IR, IY, IB, so you can see this 240 is 0 degree over 8 plus J 0.314. So we got 29.95 minus J 1.176 and indicate 29.98 phase negative 2.25. To calculate IY, 240 phase negative 120 degree over 10. So you got negative 12 minus J 20.785, 24 phase negative 120 degree. So IB 240 phase 120 degree over 8 minus J 0.011 equal to negative 15 plus J 25.996 So we got 30 phase 120.1 degree. So this is how to calculate our uh, current square minus times R. So we got 7.19 kilo for what power Y, 5.76 kilo. So power B, 7.2 kilowatt. So the total we got 20.15 kilowatt. That's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Al-Hadrami. I will be describing about the circuit that will be used in the assignment. The assignment will consist of three voltage AC voltage supply, which is V1, V2, and V3. And the resistor will be used is 3 R1, R2, and 3. One inductor L1, one capacitor C1, and 4 ground. As you can see, this is the line for R, this is the second line for Y, then the third line is for B. For the R line, it is consists of V1, which is 240 VRMS with 50 Hz and 0 degree. The wave will be used is sine, and the negative value of the supply will be grounded. And then for the second voltage supply is 240 VRMS with 50 Hz, but the angle that we'll be using is negative 120 degree. The wave is also sine, and then it will be grounded at the negative part. And for the third AC supply, it is also will be using with 240 RMS, 50 Hz frequency, and 120 degree, and it is also sine wave. The negative part is also grounded. For the Y line, for the R line, it will consist of R1, which is 8 ohm, and also inductor 1 millihenry. For line Y, it consists of R2, which is 10 ohm, and for line B is consists of R3, 8 ohm, and also one capacitor C1, which is which has a value of 300 millifarad. And then the circuit will be in unbalanced star connection, as you can see here. Okay, that is all from me. Thank you.
Right, Assalamualaikum. My name is Akmal Rusyaidi, and now I will discuss about the simulation of my team's circuit. Right, so for the circuit, I use 3 multimeter to act like a ammeter to measure the current for line R, line Y, and line B, the 3 line. Right, so let's run it. Right, so for the first ammeter, it is used to measure the current for line R, and the value is 29.977 ampere. For the second ammeter, it is used to measure the current for line Y, and the value is 24 ampere. And then for the third ammeter, it is used to measure the current of line B, and the value is 30 ampere. Right, so that for the current. And then for the total power, I use 2 wattmeter method to measure the total power. For the first wattmeter, the voltage is connected to line R and line B here. And for the current, it is connected to line R, and the result is the value shown is 7.029 kilowatt. So for the second wattmeter, the voltage is connected to line Y, yeah, and then to line, the second connection is to line B, yeah, and then the current this connect to line Y here and here. So the value shown is 8.64 kilowatt, and then we add it together to get the total power, which is we get 19 kilowatt something, and it is approximately same as the result that we get from the calculation of the total power. So from this simulation, the result for the current and for the total power is approximately same as the result that we get from the calculation. Alright, that's all from me. Thank you.